Join. So I'm starting. Can you hear me? Hello, can you hear me?
Yes, ma'am, we can hear you.
Okay. Now, before starting, just see one thing. If we go to slide changing mode, the slide is changing on. You are seeing the first one only. Slide is changing.
Yes, ma'am, it is changing.
Okay. Now, some people were having problem. So first, we will start with motor control circuits. Now, basically, motor control circuits representation, that is basically equivalent to that to some extent to the single line diagram you have done for the power system. That is in the shop floor, because drives is a subject which is application of all the things you have studied. That is the machines theory, then the power electronics, then the power system protection and everything. It is a combination of all this. So basically, in the shop floor, where say for a large power by large shop floor, the motors are used for driving different equipments, and the control room is not on the just on the shop floor. It is something physically some other location, so there will be lots of amount of connections and wirings. So if we just draw the circuit diagram, what we define by circuit diagram, it will be very cumbersome. So basically, the basic control scheme that is expressed by the control circuit. Now, this is basically single line diagram. You can see that we do not have brought out two terminals to and connect to all the equipments and like that. But this who is working on a shop floor should be able to read this control diagram. So these representations are universal. That is, this one I have shown here. This is a DC motor. Wherever you go in the world, in each and every country, DC motor is represented by like this. We will have these brushes shown. Now this is resistance. Resistance sometimes also you will see that it is represented by a small box with two terminals. This is the two terminal resistance. This is here. This is the field, and this is the relay coils. This is a contactor. It is a normally closed contactor. Means this line shows that it is normally closed and it is normally open. Normally closed means when not excited, it is closed, and when it is activated, it will open. And normally open means it is normally open. When activated, it will close. So we will explain a few motor control circuits. These motor circuits, you know, basically the control or the starting procedures you have already studied. Only the representation of those in a semi-automatic starter setup. Now, say this you have started DC motor and DC motor starting. We all know that DC motor requires a starter, And the requirement of starter is basically to reduce the starting current, because DC motor, the starter does not provide the starting torque. The motor develops the torque, but the fact is that initially when the speed is zero, back EMF is zero. So if we apply directly the rated voltage to the armature, so then the current drawn by the motor will be excessively high, because armature resistance is very small. It is a DC device, so inductance is not effective. So current will be 200 quite large, which will burn will burn the machine itself. So to limit the current within a specified value, normally 2 to 2.5 times the rated current, starter is used. So classical starter, what you have, we have a number of resistances. So the classical starters you have used in the laboratory, it has a handle which we slice over the resistances, and each and every node, the resistance, a portion of the resistance is cut off. Now the same thing we can have in an automatic starter like this. Now this is a representation of DC shunt motor starter using voltage sensing relay. So voltage sensing means voltage. This is voltage actuated relays basically. So what we have now in this circuit, this portion, what I have drawn with thick line. This is the power circuit basically, and this portion is the control circuit, which is controlling the power flow in this power circuit. So this is a shunt motor. So this is the armature. This is the field connected in parallel. I have not shown the main switch and other things. So in the circuit, what we'll have, I have only shown three resistances, but there might be a larger number of stages. So if we want, we will just add up the resistance, and additionally this conductors and these relays are also will go up. Now I have shown three resistances. Now this is a overload protection. Only this system only has one protection, overload. So this overload sensor is there. Now this is the main contact. There are three relays: 1AR, 2AR, 3AR, and these are normally open contacts. Now in the control circuit, we will have a stop button and this is a start button. And stop and start button, both what I have shown here, these are push buttons. This is a normally closed push button. It is a normally open push button. The start is normally open. So this is normally closed. So when we press this button and this circuit is closed, so this coil M, this is the overload contact which is normally closed. So this coil M will get power supply. So as the coil M is excited, it has a contactor. It will activate all the corresponding contactors it has in the power circuit as well as the control circuit. So which are the contacts? There is a contact in the power circuit M here, which will close. That means this armature circuit will be closed and the armature will get power, and this is excited with all the three resistances in series with the armature. So these resistances basically control the current flowing through the armature. Now there is a contact M here also, which is a sealing contact, because this is a push button. So once we remove our hand, this will open. So this is basically bypassing this push button. That is, once M is excited, this contact will close. So this is the holding contact which will hold the coil. Push button will open. That is immaterial. So there is another contact here also. This will close and this portion of the circuit is connected. Now what we have now? What happens once we switch on? There will be a current in rush, because the EMF, back EMF is zero, so current will be very high, but the motor starts. Now these resistances are selected in such a way that it is within 2 to 2.5 times the rated current. Now, as the motor speeds up, back EMF will increase, so the current will start decreasing. Now, what is this relay sensing? This relay is sensing this voltage drop across this, that's the back EMF, the induced EMF in the armature plus the drop in these two resistances. So once this voltage, this relay has some this is a voltage actuated, so there is a particular voltage at which it is actuated. When that the summation of these three voltages is equal to the actuation voltage of this relay, so this relay is actuated. So when this relay is excited, this will close its corresponding contact in the control circuit. So one AR will close. So when one AR will close, so this circuit is complete. So this 1A, this relay in the control circuit will be excited. So this in turn will close this contact 1A. So when this contact is closed, so this portion of the resistance gets shorted. So the resistance in the armature circuit reduces. So the current again shoots up. So now this relay, what is the relay? This is reading that back EMF plus the drop in this resistance. So initially when the resistance is cut off, the current will shoot up, and as the back EMF increases, it will again gradually decrease. Now when the voltage of this relay across this voltage across this relay, it is this voltage plus this voltage drop across this, become equal to the actuating voltage of this relay. So 2AR is excited. So when 2AR is excited, this 2AR, this contact here will close, and this 2A is activated. When this relay in the control circuit is activated, so this contact 2A will close. When this relay this contact closes, so this portion of the resistance is also cut off. Again, there will be a current inrush. Then, and after a few seconds, again the current will start decreasing. Now, this is the turn of this relay 3AR. This is basically reading only the back EMF. So, when the back EMF sufficiently increases so that it equal to the actuating voltage of this relay, so the relay 3AR will be excited. So this 3AR will close. So this will actuate this relay 3A in the control circuit, which will close this contact. So this resistance will also cut out. So now the motor will run without any resistance in the armature circuit. So if we want to have larger number of steps, we will have to just add up resistances, then the conductance will increase, and also increase in number of relays in the power circuit as well as in the control circuit. Now note one thing, these are voltage actuated relay. Basically the actuating voltage of these three relays are same, because this is reading this voltage plus these two, this is reading this voltage plus this, and this is reading only this voltage. So basically they are actuated at the same value of the magnitude of the voltage, but at different instances they will reach that voltage. So remember one thing, this representation is not that this is the only representation of a shunt mode, DC shunt motor starter with voltage sensing reload. It can be have some other logic, but this is just one of the examples. Now this is a voltage sensing relay. Instead of that, we can have some other relay also. So this is the same circuit. that is the DC motor starter with current sensing relay. So the voltage sensing relay, it was sensing the voltage, so connected in parallel. So these are current sensing relay. So it will be connected in series. So here, however, I have showed, it is shown is a compound motor because this series field is also there. So it is also has a overload protection. This is the main contact. Then these are the three relays which are used. This is 1AR, 2AR, and 3AR. So this portion is the control circuit. So again, start button is a normally open push button. So when we press this button, so this circuit is closed. So when this circuit is closed, this main relay M gets excited. So it will close its contact in the power circuit. So the armature will get power with, and the motor will start with all the three resistances in series with the armature. Now, as M is excited, it will also close this holding coil, holding contact M, which will bypass this start push button and also close this contact A. Now, when this contact M is closed, then one AR will get excited. So one AR get excited means this contact one R get excited. So this one R will close. Now this line has a normally closed and normally open contact. Now uh, this how long the contacts will take time to operate, that is also selected. Now in this particular circuit, this contact will be faster. This contact will be faster. This is the contact of a current sensing relay. So this current sensing relay, the effect is that the relay picks up instantaneously when there is a current inrush. So as soon as the armature circuit is excited, current will be very high. So this relay picks up. So as soon as this relay picks up, this contact will open. So basically in this circuit, and this contact will be faster than the contact other these other contacts. So in this circuit, basically this line is open and this get closed when this relay is excited. So what happens, the property of the current sensing relay is such that it picks up instantaneously and will drop off when the current falls below a preset value. So we know what is the characteristic of the starting current. It will pick up, then will start decreasing. When the current falls below a certain value, the relay will drop off. When it drops off, this contact, which is a normally closed contact, will go back to its normally closed state. So this contact will close. When this contact closes, this relay 1A in the control circuit get excited. So this will close its corresponding contact 1A in the power circuit. When this contact is closed, then this relay is bypassed or short circuited. So your current path will be through this relay, then through this contact, through this relay 2AR, to R2 and R3. So this relay 2AR, as the resistance has dropped, so there will be a current inrush. The resistance has been cut off, so there will be a current inrush, and due to that current inrush, 2AR instantaneously picks up. As this is also a current sensing relay, when it picks up, this contact will open. This is a normally closed contact, so this is open. So in this circuit, this contact is faster, so this is open, and by the time due to 1A, this contact will be closed. Now, once this current inrush also will decrease because the back EMF will increase. So once the current falls below a certain value, then this relay to AR will drop off. So this contact will again close. When it closes, so this relay to A will be excited. When 2A is excited, its corresponding contact in the power circuit will be closed. This closed means the power current flow line will be like this through these two contact and through relay 3AR and resistance R3. Now, so again we have reduced the resistance, so the current, there will be a current inrush, and due to the current inrush, that relay 3AR will be excited instantaneously, and it will open its corresponding contact here. So in this circuit, this is open and this will close because this 2A has closed. So again, this current inrush will gradually die down, and when it falls below a certain value, then the relay 3AR will drop off. When this relay drops off, this contact will go back to its normally closed state. So this relay 3A will be excited. So this 3A will correspondingly close this contact 3A, and all the three resistances are cut off. So basically the same in the previous circuit and this circuit, the same work is done. That is, we are starting our DC shunt motor, and we have to insert resistance during starting to reduce the starting current. But in the previous circuit, we have used voltage sensing relay. In this circuit, we have used the current sensing relay. So the same circuit can be done in different way for different relays and contacts. Now say this is again a shunt motor starter using time delay relay. So here also the basic thing is the same, that is we have a overload device, the main contact, the armature and the resistances. Now here relay used is time delay relay. So here this is the control circuit. So we press the start button. So this main coil M is excited. When M is excited, then this contact will close. So the motor will start with all the resistances in series with the armature. Then as M is excited, this contact will close. This will hold this normally open push button. Now see that in this line, we have normally closed contact of M, and if you see the circuit properly, then even before we press the start button, this relay 1AR is excited as soon as we close the main switch. So as soon as M is excited, this will open. Now the operating time for this and this contact has to be selected properly. So this will open. Now when this open, this 1AR is now initially this contact was closed, 1AR was excited. Now this is a normally closed contact of 1AR. So when 1AR was excited, this contact was open. Now as soon as M is excited, this contact will open after a slight delay because we are using time delay relay. So of delay, so this, when this is open, so this is de-energized. Now this is a off delay timer. So off delay timer means the delay is introduced, the timer, the contacts are operating instantaneously during when the relay is excited, but the delay is introduced when the relay is de-energized. So once this relay is de-energized, after the preset time delay, this contact will go back to its normally closed state. When this contact go back to normally closed state, then this 1A is excited. Now 1A, when it is excited, this will close its contact in the power circuit. Now see that there is a 2AR. This is also our off delay timer, which is parallel with this resistance R1. Now when 1A get closed, then this resistance is shorted, so the voltage across 2AR becomes 0. So 2AR is de-energized. When again this is a off delay timer, so when 2AR is de-energized, after the preset time delay, its corresponding contact to AR in the control circuit, which is a normally closed contact, will go back to the normally closed state. When it is closed, then 2A is excited. When 2A is excited, it will close this contact 2A in the power circuit, so shorting this resistance R2. So the voltage drop across this relay 3AR becomes 0. So the 3AR is de-energized. So this contact 3AR will go back to its normally closed state, but after a time delay. So when it is closes, then this contact 3A will be excited, and this will close this contact 3A here. So all the three resistances will get shorted, and the machine will run without any resistance in the armature circuit. So the basic thing, that is to insert resistance in the armature circuit during starting, can be done by either voltage sensing relay, current sensing relay, or time delay relays, off delay timers. Now that was the off delay timer. This one is definite time acceleration DC starter using time delay contacts. Time delay contacts means the same electromagnetic relay, it can have a normal contact and the delay contact. In a delay contact, there is certain coils provided, so that there will be a delay due to the inductance provided by the coil. So here what is done, the basic circuit same, that is we have the overload, we have the main contact M, then this is the armature, these are the resistances which are in series. This is the field circuit. Here this is from some other book. So in the field circuit, the field control, there is a provision of controlling the resistance in the field circuit for speed control. So here also, as we push the start button, this contact will close. So 1A is excited. Now when 1A is excited, this contact 1A will close, and instantaneously this is a normally closed contact, you can see this will open. Now the timing for this contact will be instantaneous. So this will open, this will close. When this will close, this is excited. So correspondingly, as it is excited, this will open and this will close. And this is excited, so this will open and this will close. Then only this coil M is get excited. When M get excited, then By the time M get excited, this all these three contacts are open. So the more M gets excited means this will close and the motor will start with all the resistances in the circuit. Now, then what will happen? These are the time delay contacts, and these contacts are delays are set. So after a certain time, once these relays are already excited, now with the depending on whatever delay we have set, after certain time delay, this contact this contact will go back to this now this when M is excited, you can see that M is excited. Here is a normally close contact of M here. So this 1A is de-energized. Now when this is de-energized, after de-energization, after certain time delay, these contacts will go back to its original state. So this contact will close and this contact will open. So this contact close means this resistance will be cut off. This contact open means this relay is de-energized. When this is de-energized, then after again a certain time delay, this contact will close and this will open. So this will open means this relay is excited, and so this in turn after certain time delay this contact will close, so shorting this resistance, and this contact will open. But when if this is open, this contact is already closed, so this M will be, this is by bypassed by this contact. Now here I have a timer has been shown, that is because unless this M is excited, this contact will not close, and M will be excited after certain, might be a few seconds for certain time delay, because when all this, after all these contacts relays get excited, so we have to uh, wait up to that point. So a timer is given here, so up to that point we have to press the start button. Hit the press button, press the start button to operate the circuit. Now whatever I have discussed is the shunt motor. So this is for the current limit acceleration. This is started for DC series motor. It using series relay. Series relay means current actuating relay, actuated relay. Almost this circuit is basically almost same to what we have used in the uh, shunt motor. Now here we have the series field, then we have this current sensing relay, 3C relay, 1S, 2S and 3S, and these contacts. Now when we have this additional protection, this is the overspeed, because series motor we know overspeeding is has to be avoided. So overspeed protection is there, so that if the speed exceeds certain value, that will, it is a normally closed contact, that contact will open. So giving protection against overspeeding. That is additional for series motor. Now when we press the start button, then this circuit in the control circuit will get power. That means this coil M is excited, so this contact M will close, so the motor will start with all the resistances in series with the field and the armature. Now again, this series relays are current sensing and instantaneously picks up instantaneously during current inrush. So initially the current is high, so the relay 1S picks up. So as it picks up its corresponding contact, 1S in the control circuit instantaneously opens. But after a certain time, the current will decrease. When the current decreases below a certain value, then the relay will drop off and its contact 1S will go back to its normally closed state. When it goes back to normally closed state, then the coil 1A will be excited. When 1A is excited, it will close this contact 1A in the power circuit. When 1A is closed, then the power flow, you can see it will bypass this and it will go to 2S, relay 2S. So 2S instantaneously picks up. When it picks up, it will open its contact 2S. It is a normally closed contact in the control circuit, but the current will start decreasing, and when the current falls below a certain value, then 2S will drop off. When the 2S drops off, this contact will go back to its normally closed state. So it will be closed. This 1A will be closed because this is excited. So 2A is excited. So when 2A is excited, this one contact 2A will close. This contact 2A will close. So again, there will be a current inrush which will go through the relay 3S. So it will pick instantaneously, opening this contact in the control circuit. So after a time delay, when the current falls below a certain value, the contact where the relay will drop off. So again, 3S will go back to its normally closed state. So 2A is already closed. So this 3A is excited. So this will close this contact 3A here. So the machine will run without a resistance in the armature circuit. This is again current limit acceleration DC starter for series motor using holding coils. The same thing, our aim is same, that is we have to insert resistance as starting and cut it off. Pure holding coils has been used. See what is the difference. Now if as we press the start button, this coil M is excited. As M is excited, this contact will close. As this is closed, the motor will start or the resistance in the circuit. Now these are the holding coils for 1A, 2A and 3A. Now this holding coil is reading the voltage drop across this resistance. This holding coil reading the voltage drop across this plus this, and this one across this plus this plus this. Now these settings are different. So when the holding coil will hold the corresponding contact of this 1A as long as depending on the holding coil voltage. So when the holding coil voltage, that is voltage across this holding coil, becomes equal to the preset voltage, then only this contact 1A will operate. Otherwise, you can see that these relays are excited, already excited. Once we close the start button, and when this 1A is excited, this resistance will be cut off. Now the current is dropping, so the voltage across the actually what happens, the initially current is very large, so it is basically reading the voltage drop across the resistances. So initially the voltages are very high. Now as the current drops off, then the holding coil voltage becomes lower. So when it is less than the set voltage, then only that will allow the contact to operate. Now this holding coil initially was reading the voltage drop across this and this. Now this portion of the resistance is cut off, so reading the voltage drop across this, when the holding coil voltage is less than the preset value, then this of corresponding contact 2A will operate, shorting this resistance. Again, same thing happens to this. That is now the holding coil 3 is only reading the voltage drop across this resistance. So when the current drops to certain value and the voltage drop reduces, then this holding coil will allow this contact 3A to operate. So 3A will operate. It will short and the machine will run without a resistance in the circuit. So this circuit and with the previous one, both for the series motor. Previous one was with current sensing relay and this is with voltage sensing relay, but with holding coils. Now next things what I have is for the induction motor, but this is the basic DC motor. This is not the only, this is the basic, very basic circuits. Now if we want to add more features, so logically we can have add more relays, more controls, some other logics, so that we can have other operation also. So basically these circuits what I have shown is taken from COSO. This is Arvin COSO. This is one motor control circuit. There are it is a few circuits which I have taken from there. If you are interested, you can go through the book. This is basically like solving some problem. That is, a particular problem can be solved in different ways. So there, depending on whatever the features your client wants, the control circuit can be, all the features can be incorporated in the control circuits. So these are the basic for the DC motor. What we have seen, that we have done basically 5 circuits. That is the DC shunt motor circuit. This one is the voltage sensing relay. Then we have done for the same DC shunt motor starter with current sensing relay. Then this is for the shunt motor starter with off delay timer, and this is for shunt motor starter with time delay contacts, and 2 circuits for the series motor. Is one with current sensing relay and this one with holding coils. Next day we'll go for the induction motor starting. Now can we have a class on next Thursday? Hello?
Thursday when?
বলো এই সেম টাইম 4টের সময়।
আমাদেরকে
Actually,
একটা
আমাদের 6:30 থেকে একটা ক্লাস থাকে।
6:30? না আমি 45 মিনিট 50 মিনিটের বেশি নেব না, ঠিক আছে?
ঠিক আছে ম্যাম, কোনো ক্লাস ম্যাম এখন আপাতত কোনো টিচার আর কোনো ক্লাস বলেনি, তাহলে পরে থার্সডে নিতে পারেন।
আচ্ছা ঠিক আছে।
ম্যাম কোনো বই ফলো করার আছে কি ম্যাম ইলেকট্রিক্যাল ড্রাইভস এর জন্য?
Ma'am has left the meeting, Anish.
Yes, you should also leave because everything is recording.